A very good morning to all. I am Mr. Swapnil Saznik from Department of Mechanical Engineering, Sharad Institute of Technology Polytechnic, and I am teaching the subject Thermal Engineering. In a previous lecture, we have seen some points from this subject. We have also seen what is the weightage of this subject. Now, for moving with this lecture, I would first revise what we have seen in the previous lecture. We have seen the importance of this subject. We have gone through these 4 points. What is the need of this subject, thermal engineering? Then we have seen the weightage of this subject. I have explained that our total weightage for this subject is 150 marks. The 70 marks theory paper for passing, the students have to score 28 marks. That was the point which I was missing in previous lecture. I have not told that. We have seen what are the topics in this subject. So these six chapters we are going to study, and we have seen some basics of all the subjects what we are going to study in each topic. Fundamentals of thermodynamics, ideal gases and process, and the third chapter steam and steam boilers. And next chapter is steam turbines, steam condensers, heat transfer and heat exchangers. So in this way, we are going to study these 6 chapters under this top subject. 3 books that I have recommended. Then we have started with the first topic, that is fundamentals of thermodynamics. So before heading with this topic, I have also told the course outcome of this topic. The students will be able to apply the laws of thermodynamics to devices based on thermodynamics. We have seen what is a pure substance. Then we have gone through some definitions such as thermodynamic system, surrounding, boundary, and universe. So these definitions are also very important. We have also seen the types of system. This is the most important point from our first lecture. We have seen the 3 types of system, that is closed, open, and isolated. And I hope that with the examples which were explained in the first lecture, you will be able to differentiate all these 3 types. So once again, I will revise the closed system is the system where no mass is allowed to cross the system boundary, but energy can transfer in this case. We have seen in the diagram here, we have seen that mass is not transferring through across the system, whereas only heat is allowed to transfer. So this is closed system. And in open system, we have seen that the system where mass as well as heat is allowed to cross the system boundary. So in diagram, this is shown that mass is transferred as well as heat is also transferred. So this is the open system. The third system that we have seen is isolated system. In this system, neither a mass nor energy will be transferred across the boundary. So in diagram, it is represented as this. There is no mass transfer or the energy is transferred. We have also seen the example. I have given these examples. So these are the types of system. Next, we have seen what are the properties of system. First, we have defined what is actually the meaning of property. So any measurable or observable characteristic of the system is nothing but the property of that system. There are actually 2 types of properties, that is intensive and extensive property. I have given one example to explain the concept of this property. So I have given the example of the person named Anand. His 4 characteristics were given, that is his age, height, his graduation, and his academics. So these are nothing but the 4 properties of Anand. We have seen the 2 cases so as to determine what are the important properties during that particular cases. We have also seen the intensive and extensive property, what is the actual meaning and what is the confusing part while explaining these points. Students always have misunderstanding between while defining these 2 definitions. So have also explained during the previous lecture that how to remember these definitions. So I would like to request the students who are watching this video, they should definitely go through the first video so that they can understand all these concepts properly. So in intensive property, we have seen that it is a physical property which is not dependent. This is most important words. These two words are very much important. Intensive properties are not dependent on the size or mass of the system. And the examples are given below, that is pressure and temperature. Whereas in case of extensive property, these are the properties which are dependent on external parameter, that is the size or mass of the system. So these extensive properties will be dependent on size or mass. Examples are given, that is volume or mass. A few more examples also are given in next slide. Here we can see what are the examples of these properties in exam. These examples are also asked, so I request you all to remember these examples. Next, we have seen what is a flow and non-flow process. Then in first point, we have seen what is a flow process. It is one in which fluid enters the system and leaves out of the system after work interaction. So this flow process is somewhat similar to the open system. And example, I have given the example of boiler. In boiler, what happens? Actually, water enters the system, and after giving when we are giving heat to that system, then this water is converted into steam, and this steam goes out of the system towards the turbine. So this is nothing but flow process. We have seen non-flow process. It is the process in which there is no mass interaction across the system boundaries. So this is similar to closed system. The examples are given, a cup of tea on which a plate or cover, a lid cover is placed on the top. In this case, we can see that there will be no mass transfer, but the exchange of energy will take place. A second example for non-flow process was given, that is the compression and expansion stroke of IC engine. In case of IC engine, when there is compression or expansion stroke, then that time these two valves, that is the inlet valve and the exhaust valve, are closed. So there will be no transfer of mass, but during these two strokes, there is the transfer of energy. This is the non-flow process. Then again, we have seen some definitions. Specific volume. It is nothing but the ratio of volume to the mass. That is specific volume. Next, we have seen density. It is defined as mass per unit volume. Then we have seen what is the meaning of temperature. So it is the physical property of matter that expresses the degree of hotness or coldness. We are measuring this temperature with the help of thermometer. We have seen the three scales for measuring the temperature, that is degree Celsius, Fahrenheit scale, and Kelvin scale. Kelvin scale is the SI unit for measuring the temperature. Then we have seen pressure. So pressure is nothing but force per unit area. SI unit for pressure is Pascal. 1 Pascal is nothing but 1 Newton meter square. This formula can be easily remembered by either remembering the unit, or directly we can also remember the definition of this point, and in that manner we can write its unit. Now the most important thing, I am also going to refer the MSBT paper, that is the final paper which you are going to give for 70 marks. I am, after every lecture, I am to refer 3 previous MSBT paper, and whatever we are studying in this lecture, from that part only we will see what are the questions, or most important questions which have came in the recent 3 papers. So what we have seen in first lecture, from that only I have taken some questions from 3 MSBT question papers, so you can also revise them. You will understand what are the important points from this lecture. So in first lecture, we will now see what are the important questions which have came in the previous 3 papers. So the first question was related to the intensive property and extensive property. The students were asked to define these properties, and also the examples for each was asked. So this question was recently asked in the paper Winter 19 for 2 marks. So 1 mark for intensive property along with its example, and 1 mark for extensive property along with its example. So this was Winter 19 question. The next question was define extensive or state a extensive property and intensive property, and along with again the example. So you can see that in summer 19 also this question was repeated, but this time it was asked for 4 marks, and here two examples were asked. So again here intensive property with examples will carry 2 marks, and extensive property will carry 2 marks along with 2 examples. So from first lecture, I have referred 3 papers, but in one paper there was no any question from the part which we have studied till now. So you can refer these questions from the MSBT papers. Now we will move further with our second lecture. So today we will see what is the thermodynamic process and cycle. First, before going to study thermodynamic and process, we will first see what is the meaning of actually thermodynamic state. Because while defining the process and cycle, this term, that is thermodynamic state, is very important. Thermodynamic state is defined as it is a condition at a specific time, which is fully identified by a set of values such as pressure, volume, or temperature. Uh, we can refer this diagram so that you can understand what is the meaning of thermodynamic state. Here we can see there is a curve which is starting from A and ending at point B. So if we are going to study what is actually the meaning of thermodynamic state, then we will consider just these 2 points, that is point A and point B. If we consider point A, then at point A there will be some specific value on x-axis and y-axis. For example, if on this axis we are having pressure, and on this axis we are, or we can say that on y-axis pressure is given and on x-axis volume is given. Then for point A, this point A will have a unique condition, that is it will have a specific value for pressure as well as volume. So we can define this point A by referring to these two axes. We can say at, for example, at point A we will be having 10 bar pressure, and here we will be having some value of volume, say about 3 meter cube. So if we say that at 10 bar pressure and 3 meter cube volume, then with these two set of parameters we will get a point that is nothing but point A. So this point A is nothing but called as state. So thermodynamic state is nothing but it is a condition which will have a specific value for pressure and volume. Okay, I understand. I think that you must have understand what is the meaning of state. And just simply remember that it is nothing but a given condition which will have specific values of a suitable set of parameters such as pressure, volume, or temperature for at a specific time. So this is nothing but a thermodynamic state. Now we'll see what is the thermodynamic process. Thermodynamic process is nothing but change of state from one point to other. As shown in this figure, we can see that a curve is placed in front of x and y axis. So on this axis, that is x and y axis, we will have some thermodynamic properties such as pressure, volume, or temperature. These points A and B are nothing but thermodynamic state. For determining a thermodynamic state, a minimum of 2 thermodynamic properties are very much essential. In this figure, we can see that the system is changing from one state, that is from state A, to another state, that is state B, along some definite path. So this curve A to B is nothing but we call it as thermodynamic process. I will repeat the definition. The thermodynamic process is nothing but it is a change of state of system from one state point to another in a determined path. So this is the concept of thermodynamic state and thermodynamic process. Now we will see what is thermodynamic cycle. So thermodynamic cycle is a series of two or more processes to form a closed loop where the cycle or the process will reach to its initial point again. We will study this with the help of this diagram. So in this diagram we can see that there are actually two processes, that is process 1A 2 and the another process is 1B2. But here the most important thing is that we should see these arrows. This shows that the process is starting from point 1. It goes along this path A, reaches another state, that is point 2, and then the process again returns back to state 1 via path B. So as per this definition, we call this as a cycle because here the initial and final state of the system is same. That is, the process begins with point A, goes to 2 via path A, and then again return back to point 1 or state 1 via path B. So we call it as a cycle. Many times students ask one question that as shown in this diagram, here the initial and final states of the system are same because we can see here the arrows. When the process is moving from A to B, but again we are seeing this arrow, that means that again the system is changing from B to A. So in this case, should we call this as a cycle or not? So the answer to this question is that we do not call this diagram as a cycle because here, though the initial and final points of the state or the initial and final points of the system are same, we cannot call this as a cycle because here in this diagram there is no any closed loop is formed. So the states are changing from A to B, and again even if it returns to the same initial point, but since here no any closed loop is formed, we will not call this as a cycle. So this is just a process, and as shown in this diagram we can see that the here this is the closed loop. Since this closed loop is formed here, we call this as a cycle. So this was all about thermodynamic state, thermodynamic process, and thermodynamic cycle. Now we will see what is the meaning of quasi-static process. Many years back, this question was asked in the paper for 4 marks. So we will see the concept of this quasi-static process. A quasi-static process is one in which the system deviates from one equilibrium state by only infinitesimal amounts throughout the entire process. The meaning of this is nothing but if the process is changing from one state to another by only a small amount. This infinitesimal means a very small change or very small change in the state. So if the process deviates from one point to other by only a small amount of change, then we call such process as a quasi-static process. We will see in this diagram here pressure versus volume axes are given. We can see that the system is changing from state A to state B. We call this curve as a process, as we have seen in previous slide. So here there is change in state from A to B. Here we can see number of arrows are placed on this process. So these arrows indicate nothing but these are the different states through which the process is changing. So if we consider any two arrows from this process, then the difference between these two arrows, that is the difference between these 2 points of states, will be very much small. So such process is called as quasi-static process. We can further understand this concept by taking some examples in further slide. Let us consider that for explaining quasi-static process, we will consider here example of piston cylinder arrangement. So here you can see the red color indicates a cylinder, and this is a piston, and on this piston several weights are put. There is a gas in between this cylinder and piston. So if we assume that this gas is a pressurized gas, now if we remove the weight slowly one by one, the pressure of the gas will displace the piston gradually. So these are the weights. Here we can see that on this piston two weights are placed. So if we consider that if we are removing this weight slowly one by one, then what will happen? This gas which is stored here, this gas will push or kick the piston slowly upwards as we are removing these weights one by one. So this is called as quasi-static process. On the other hand, if we move all or if we remove all these weights simultaneously or at once only, if we remove all these weights, then this pressurized gas will kick the piston at a single stroke. So in this case, we cannot call it as a quasi-static process. Another example, this example is very simple so that you can understand it very clearly that what is actually the meaning of quasi-static process. Another example is, let us assume that a person wants to climb down from from a roof to the ground floor by using a ladder. Then here in this diagram you can see that this person is coming down to the ground from the top of a building or say a roof. So this person, when he climbs down, then while using a ladder, he is coming down slowly, that he will be using each step to climb down. So this is called as a quasi-static process. On the other hand, if we consider that the person is jumping off from the top of the building to the ground floor, then there will be a large impact, and in this case, we do not call it as a quasi-static process. With this example, I think that you will betterly understand what is the meaning of quasi-static process. I will repeat once again. Quasi-static process is the one in which the system deviates from one equilibrium state by only infinitesimal amounts throughout the entire process. Then we call it as a quasi-static process. So this was the concept of quasi-static process. Now we'll see what is the path function. So path function is a function whose value depends on the path followed by the thermodynamic process, irrespective of the initial and final states of the process. The examples of path function are nothing but heat as well as thermodynamic work or work done in a thermodynamic process is dependent on the path followed by the process. We'll study this with the help of a diagram. What is the meaning of path function? So let us again consider the PV diagram. The pressure versus volume diagram is given. Here we can see. I would like to ask, we have studied what is the meaning of thermodynamic state, process and cycle. Can anybody tell me what is this as the given diagram? Is it a cycle or not? So the answer to this question is you cannot say this as a cycle because here you can see that the two arrows are marked in the same direction. Though there are two processes involved in this diagram, but since the arrows are in the same direction, we can say that the system is changing from state 1 to state 2, but it is not again coming back to point 1. So we cannot call this as a cycle. You should understand the difference between the diagram which we have seen in case of cycle and this diagram. In case of cycle, we were having we were not having the direction as shown here. There was exactly opposite direction shown. In case of cycle, the process was going from 1 to 2 and again returning back from 2 to 1. So this is not happening in this case. So we are studying now what is the actual meaning of path function. So here we can see that the system is changing from state 1 to state 2, but this system change can take place via two paths. That is, it can change from 1 to 2 via path A. Also, it can change via path B. So, if the function, as given in examples, we have seen that heat and work are given as the examples of path function. So, in case if we consider the example of work, then how do we calculate work? And with the help of this diagram, we can calculate work by taking the area under the curve. So if we consider the area under the curve A, then in this case, if we are just considering the process, first process, that is process 1A2, that is this 1A and 2. So in this case, if we want to calculate what is the work, then we will consider the entire area below this curve. So this will be the entire area what we will going to consider. This Let us consider that this work or the area under this curve is nothing but WA. So if we assume that this work is to be 10 kilojoule, now if we consider another path, that is path 1B2, then again to calculate work we will consider the area below this curve, that is 1B2. So here we can see that as compared to path A, here the area will be somewhat lesser. So let us assume that this area under the curve is about 7 kilojoule. Then from this we can clearly understand that while the change in state from 1 to 2, if the system changes from state 1 to 2, then if the system passes through path A, then it will require more work, whereas in case of path B, the system requires less work. So this is given here. For process A, the work will be 10 kilojoule, and for process B, that is WB, work will be 7 kilojoule. So here we can see what is the difference. For path A, the work will be 10 kilojoule, and for path B, the work is 7 kilojoule. So here what is happening? The system is changing from state 1 to state 2, but the path which it has taken, it will give us the value of the function, that is in this case here our function is work. So for path A more work is required, and for path B less work is required. So this is what we are explaining, that path functions are the functions which are not dependent on the end states, but it is dependent on the path followed by that system. So heat and work are nothing but we call them as path functions. Now we'll see what is the point function. A point function, also known as a state function, is a function whose value depends on the final and initial states of the thermodynamic process, irrespective of the path followed by the process. So this is somewhat exactly opposite to what we have studied in the previous slide, that is path function. Some of the examples of point function are the density, enthalpy, internal energy, entropy, etc. Since a point function is only dependent on the initial or final state of the system, for a cyclic process, the value of thermodynamic function is 0, or the change in thermodynamic property is 0. We'll again see this with the help of a diagram. Again, we will consider the same example. Here we can see the PV diagram, pressure versus volume diagram. Again, here two processes are given. The system is changing from state 1 to 2 via two paths, that is path A and path B. So for point function, if we consider path A, then in this case, if we are focusing on the parameter volume, if we are calculating volume, then for this change, that is from if the system is changing from state 1 to state 2, then the change in volume we can calculate in this way. We can directly get the values from by extending this point 2 and point 1 on the x-axis. So we will get the values V2 minus V1. Let us assume that it is coming about 3 meter cube. So even if the system is changing via path A, or it may change via path B, for determining the value of change in volume, we are just going to take these values, that is V2 and V1. So in both the cases, that is for process A or process B, we will be getting the same value, that is 3 meter cube. This shows that this property or this change in volume is not dependent on what path the system has taken, but it is dependent on the end states. This point 1 and point 2 are the end states. So the change in volume is just dependent on these end states and not on the path which it has taken. So this is the concept of point function. Just remember these 2 points, because many times this question is asked in the paper for 4 marks. So you should know what is the actual meaning of point function and path function along with their examples. Now we'll see what is the difference between point and path function. We will just have a summary of what we have studied in the previous two slides. So we can differentiate in 4 points. In case of point function, any quantity whose change is independent of the path, we call it as point function. Whereas any quantity whose is dependent on the path followed during a change of state is called as path function. Next, the magnitude of such quantity in a process depends on the state, whereas in case of path function, the magnitude of quantity, as in example we have seen about the work. So the magnitude of work, which was given as 7 kilojoule or 10 kilojoule, that 7 and 10 are nothing but the magnitude. So the magnitude of this quantity will be equal to the area under the curve on a property diagram. We have seen this during the path function. Point function are exact differential, whereas path functions are inexact differential. This concept, that is exact and inexact differential, are the terms used in thermodynamic process to show that whether they are dependent on point function or path function. Next, the examples are given for differentiation. That is, in case of point function, the examples are given, that is pressure, volume, temperature, energy, etc. All these are point functions, whereas heat and work are the path functions. Now we'll see what is the concept of thermodynamic equilibrium. We are going to study the three types of equilibrium, that is mechanical equilibrium, chemical equilibrium, and thermal equilibrium. So first we will see what is the mechanical equilibrium. Mechanical equilibrium. A system is said to be in mechanical equilibrium if the resultant force acting on the system is zero, or simply we can say that no unbalanced force is acting on any part of the system. If we see the word equilibrium, then this word itself means that uh, at every point in the system there should be same properties. So since we are talking about mechanical equilibrium, we are considering the forces. So if in the system there is a balanced force at every point or throughout the system, then we call it as mechanical equilibrium. We can understand this concept with the help of diagram. So let's see the diagram. Here in this figure, we can see that a number of small pebbles of rocks are placed one above the other. So here, since we can see that there is a tall structure formed by placing the rocks one above the other. Since here the forces are balanced, this structure is erect. But if any kind of unbalanced force was acting on this system, then this structure would have collapsed. So this structure is the example of mechanical equilibrium. Another example we will see here.
In this diagram, we will see that a child is hanging on the rope. Since the both the ropes are exactly vertical, we can say that there might be same forces acting on both the ropes. Okay, so this is the condition of balanced forces. However, if we see in the second figure, the child is inclined with some particular angle, or we can say that the ropes are making some angle with the horizontal. So this is the symbol of unbalanced condition.
So with these two figures, you can understand what is actually the concept of mechanical equilibrium. Simply, you just remember that a system will be called as in mechanical equilibrium if there are no any unbalanced forces in that system. Next, we will see what is thermal equilibrium. A system is said to be in thermal equilibrium if the temperature of the system does not change with time and has same value at all points throughout the system. Here simply we can say that system will be in thermal equilibrium if the temperature throughout the system is same. Then that in that case we will call the system is in thermal equilibrium. So let us consider this example. Here we can see that a body whose temperature is maximum, we can just consider, for example, it is say 100 degrees Celsius, and another cold body is placed here. We can assume that this temperature is say about 0 degrees Celsius. Then when we placed these two extreme condition bodies in contact with each other for some time, then after a certain duration of time, we can see that a thermal equilibrium condition is obtained. So at this condition, we can see that the temperature, if we measure the temperature throughout any part of the system, then we will get same or uniform temperature throughout this structure. So just we will see this in the figure. So this is what I was telling. If we assume that 0 degrees Celsius is the temperature of this cold body, and 100 degrees Celsius is the temperature of this hot body. And after some time, the heat will travel from this high temperature region to low temperature region. And after some time, an equilibrium condition will be achieved, and it might be about, say, we are just taking an example that the equilibrium condition is obtained at 50 degrees Celsius. So when these two extreme conditions are placed in contact with each other, then after a certain duration of time, an equilibrium condition will be obtained. That is, if we are going to measure the temperature at any part, even if we measure at this point or this point or at the middle, the temperature throughout the system will be same. And this condition is called as a thermal equilibrium. So in thermal equilibrium, we are focusing, or the main parameter of our interest is the temperature. So any point, if we measure temperature at any point, then throughout the system we will get same temperature. So this is the concept of thermal equilibrium. Next we will see what is chemical equilibrium. A system is said to be in chemical equilibrium if there exist no any chemical reactions or transfer of matter from one part of the system to another. So likewise, as we have seen here previously, what is mechanical equilibrium and thermal equilibrium. Similarly, in case of chemical equilibrium, there should be no any chemical reactions taking place, or there should be not a transfer of any matter from the system to the surrounding. Then in such case, we call it as chemical equilibrium. Now, if we see summary related to this thermodynamic equilibrium, or all definitions we can see in short here. That is mechanical equilibrium. Simply in three words, we can say that there will be no any unbalanced force. Next, in case of thermal equilibrium, we can say that there will be no change in temperature throughout the system. And in case of chemical equilibrium, there will be no any chemical reaction in that system. So this was the concept about thermodynamic equilibrium. So today we will stop here and start with a new point, that is the concept of heat and work, in the next lecture. Till then, I would request you all to go through all the points which we have discussed today, so that we can discuss some questions from today's lecture, which was asked in the MSPP paper. So thank you very much for listening to my lecture. I would also like to ask you all to subscribe my channel to get more lectures on this subject. Thank you.